Okay, if you had to explain density to someone in 3 sentences or less, who thinks they could give me the gist of density in 3 sentences or less? Think about what we talked about yesterday. Think about this picture. 3 sentences or less. What do you think, Addie J? Okay, density is how tightly packed particles are. That's 1 sentence. Aubrey?
The less tight the particles are, the less density it has.
How could we add a few more words to tell us everything we need to know to do this worksheet? So, less dense means less tightly packed particles, and less dense. What happens to less dense things? They float. More dense is more tightly packed particles, and they sink. Okay? In the fewest words possible. More dense sinks down, less dense sinks up. Density is the amount of, or how tightly packed the particles are. What did I say?
Sinks up.
Oh, sinks up, goes up. Okay, so on here, says use the diagram to fill in the blanks. I can't have them. Let me see if I can shrink it enough to see it all. There we go. The water is less dense than blank. So we're focusing on water right here. If it is less dense than something, is it floating above that something, or is it just below that something if it is less dense? Kenley? It's floating above. So what is it less dense than? Emma? The corn syrup and the block. It does not matter which order you have those in. Are there any other options that I could put there? No, those are the only 2 options. So I'm going to write block and corn syrup, but you could have those flip-flopped. Because if water is less dense than them, then it should be floating above them. The ball is denser than blank. If it's denser than something, it should be sinking down below it. Elise?
Vegetable oil.
Hold on, the ball is floating on top of the vegetable oil, so the ball is less dense than vegetable oil because it's floating on the top of the vegetable oil. But it's denser, which means more or less. If it's denser, does that mean more dense or less dense, Addie? More dense. So what is it sinking down below? The lamp oil. So this one right here should be lamp oil. Blank is less dense than water, but more dense than vegetable oil. So we have to look, we're focusing on vegetable oil and water. I already have water highlighted. So less dense than water. If it's less dense than water, Augie, what's it going to do to the water? Yeah, so I'm looking above water, so it has to be above the water. So we're looking at the bead, the vegetable oil, the ball, the lamp oil, but denser or more dense than vegetable oil. Ava, what does that tell me? It tells me it has to be the bead. Why? There's nothing else that's above the water and below the vegetable oil. So yeah, it has to be that bead right there in the middle because it's kind of floating on top of the water, but it's at the bottom of the vegetable oil. So the bead is less dense than water, but more dense than vegetable oil. Blank is the least dense labeled substance in the beaker. Lexi, what is the least dense substance in the beaker? Lamp oil. How do you know that? Because it is at the top. Good job. The block is the most dense substance because it has the most, this one's, we didn't talk about this, so we'll see what you had. Addie? Most mass, good job, per unit volume. We did talk about mass, higher mass equals more density, but if you didn't get this one right, I'm not too worried about you. But with the volume, with density, it actually has a formula, a mathematical formula. What's a formula? Like an equation to help us find it, like area. You know the area of a rectangle is length times width. That's its formula. For density, it's mass divided by volume. Is actually to find the density of object, you can take its mass and divide it by its volume. The amount of matter in an object divided by the amount of space it takes up. But again, we didn't talk about that, so if you missed that one, I'm not worried about you at all. Of the solid objects in the beaker, so we're focusing on solid objects, which one is the least dense, Hutley? The ball, because out of our solid objects, the ball is the closest to the top. Which one is the most dense solid, Carter? The block. Raise your hand if you didn't miss any. Good job. Raise your hand if you just missed mass. Okay, good job. Okay, I'm going to pull up one more. Does anybody remember what these things are called? Density towers. Why do you think they're called density towers? Kinley?
It shows how dense each one is and they're on top of each other.
Yeah, they kind of stay towered like levels, stories. Let me pull up another one. Test your density skills here. Maybe. Okay, looking at the density tower on the board, you know, isn't it beautiful?
Very white.
Which substance is the least dense? The white substance. Which one is the most dense? The white substance. Oh, here we go. There's my little bubble. Let's see if a density tower pops up. Doesn't even show that it's loading. See if that gets us there faster. Let me pause this, see if that helps. Okay, now that we actually have a density tower up here, I know it's kind of grainy, but you can kind of still see the words. Just looking at colors, who can tell me one color that is more dense than the yellow? More dense than the yellow color, and we'll talk about like this yellow color right here. More dense, than the yellow. Jackson?
Milk.
Milk? How do you know that milk is more dense than that dish soap?
Because it's below.
Because it is below. Elise, is there anything else that is more dense than the yellow dish soap? The maple syrup. Emma Kay? The corn syrup. Elia? The honey. Anything else? Carter? The bolt. Lexi? The popcorn kernel. Lainey? The dye. What's a dye? Elise? Yeah, a singular dice. Now let's focus on that dice. We're looking for more dense than the dish soap. The dish soap, the top of it's there, the bottom of it's there, and the dice is right there. So how do I know that the dice is more dense than the dish soap, Kinley?
Because if it was less dense, then it would be floating in it, and since it's sinking.
Yeah, it's at the bottom of the dish soap, so it's more dense than the dish soap, but it's less dense than what?
Milk.
The milk, okay? Who can tell me something about the rubbing alcohol? Just tell me something about density and the rubbing alcohol. Fisher?
It's more dense than plant oil, and it's the same density
So-
as a soda cap.
Okay, so it's more dense than lamp oil. I agree with that. The soda cap's really hard to see. I think it's floating kind of right there. So rubbing alcohol, what did you say about the soda cap?
It's like the same density as
Okay, it's not the same. It's probably just slightly, the soda cap is probably a little bit more dense because it's floating right at the bottom of it. Okay, who can tell me something about the cherry tomato? It's kind of right there, the cherry tomato. And again, I know this is hard to see. Mason, can you tell me something about the cherry tomato?
It's less dense than, or no, it's more dense than water.
Okay, it's more dense than water. What is it less dense than, Gabe? The cherry tomato. I have it circled in red right here. The cherry tomato is less dense than what? Milk, I agree. What else, Addie? Dish soap, I agree, because it's floating right at the top of the dish soap. Addie J, you got something else? Maple syrup. Really, anything under it. Okay? So you do have a worksheet tonight over density, and it's a picture very comparable to this one, and it just asks you a whole bunch of questions about that one picture. Okay, is there any questions about that? No? Okay, pull out the lesson 2 and lesson 3 review that I just passed back.
Where do you want stuff like that?
Hold on, well, we're going to put all of this together in your just folders in just a second. So pull up, find the lesson 2 one first. That was the full page one. The full page one. We're going to go through, if you missed them, I marked them, but I did not correct them. Okay, so get out a pen or a pencil. If you missed some, I want you to fix them. Oh. Yeah, hers is on my desk if you don't mind. Okay, number 1, and this is lesson 2. Number 1, the blank of an object is a measure of how fast its particles are moving, Emily. Temperature. Temperature. Now, let's talk about temperature. Warmer objects, what do the particles do, Addie? Move faster. They move faster, move faster. And think about for water to turn into ice. Think about the particles slow down because they eventually become frozen. When you're frozen, you're not moving. Okay? The particles are slowing down as the temperature decreases. That was some questions later on that I don't think we fully understood, some of us. Number 2, blank is a physical property of matter. It can be observed with your own 2 eyes. Carter? Color. Number 2 is color. Number 3, the amount of matter in an object is the object's what? Jackson? Mass. Good job. That is the definition of mass, the amount of matter in an object. Lexi, 4. A blank is the tool used to measure the volume of a liquid. Yes, graduated cylinder. Okay, number 5. Degrees blank is used by scientists to describe how hot or cold matter may be. Ava? And what did I put next to yours? What does that mean? Do you remember? Okay, yeah, so if you put Fahrenheit, I gave it to you because that is a measure of temperature. But most scientists actually use Celsius. So if you put Fahrenheit, I gave it to you because that is a temperature measurement. But go ahead and write in Celsius. Okay, most scientists use Celsius. That's like the uniform measurement. Where do they use Fahrenheit? In the US. Okay, and that's it. So Celsius is more a general, used by the world, a general measurement used by everybody. So if you had Fahrenheit, I gave it to you because that is a temperature label, but it is actually Celsius there. Number 6, when measuring blank, a scientist is describing how much space an object takes up. Addie B. Volume. The definition of volume is how much space an object takes up. Number 7, blank is not the same as mass because it changes depending on the gravitational pull of where the item is located. Braylon? Weight. Weight and mass are comparable. Weight is affected by gravity. Mass is not. And McKay, number 8. When measuring blank, a scientist can use his or her sense of touch to tell if the object is smooth, rough, lumpy, sticky, or spongy. Texture, good job. Number 9, mass is measured by using a blank. Wyatt? Balance. You must use gram cubes or objects known as mass to measure of known mass to measure using this tool. Yes, it is balance. If people miss this, they put scale. What do we use a scale for? Not mine. Let me see it real quick.
I think it's a student's.
No, it's not yours, is it, Miss Megan? Nope. Okay, nope, not ours. What do we use the scale for, Carter? Weight. Okay, are weight and mass similar? Yes, but they're not the same. For a balance, you have to put stuff on both sides because we know those little cubes are worth 1 gram. So we we measure it to a known amount. A scale, we just get on it, gravity pulls us down and gives the weight. Okay, comparable but not the same. Number 10, when using a balance to measure the mass of an object, scientists could use blank as the unit of measurement. Lainey? Grams. Yes, good job. Grams. Okay, at the bottom it was true, false, and why, or fix it if it's false. And these ones, some of these were tricky. You had to read carefully. So number 11 at the bottom says an object that has a temperature of 110 degrees Fahrenheit has slow moving particles. Lexi? Okay, why did you say false? Okay. Okay, what makes you think that they have fast moving particles and not slow? Yeah, because if it was 110 degrees Fahrenheit, that's why we used Fahrenheit, because we know that. If we walked outside and it was 110 degrees Fahrenheit, would I be wearing a sweater and jeans? No, because that's a very high temperature. High temperatures, the particles move very fast. So on that one, you had false. You should have marked out slow and wrote in fast. What else could you have changed? No one did it this way, but there's something else we could have changed. Addie?
You could have changed the temperature to
Yeah, we could have changed like 110 degrees Fahrenheit to like 30 degrees Fahrenheit. That would have also been an appropriate way to change it. Usually in these, there's 2 different ways where you could change them and change it correctly. Number 12. Solids, liquids, and gases all have volume. Elise?
True.
That is true. This is probably the most missed problem on here. Why did we think that was not true? Hutley?
Because we said matter, or like cross volume out.
Okay, they are, and some of you created another true statement, but it wasn't false, so we didn't have to change it. So some of you put false and then wrote in another true statement. Carter?
Because you can't see gas.
Yeah, we can't see gas, but does gas take up space? Yes, okay, and that's what's kind of confusing, but this one was true because they all have a volume, but the gas's volume changes depending on the container it's in, because it takes up the space in whatever container it's in. But it does take up space. We just can't always see it. Number 13. The mass of an object on Earth is different than its mass on Mars. The mass of an object on Earth is different than its mass on Mars. Addie, that is false. How could we make that true? Okay, we could change the word different to the same. Because gravity has no effect on mass. Mass is mass. It doesn't matter where you're at. If you're measuring mass, you will always get the same number. What is affected by gravity? Not volume, not matter. Weight. So you also could have changed the word mass to weight, because then they would be different. Most people did it that way. Number 14. Mass is the amount of space an object takes up. Ava, that is false. Two different ways. What is mass? We could have given the mass definition. Mass is the amount of matter in an object. Or what is the amount of space an object takes up? Elise? Volume. A lot of people marked out mass and wrote volume. Or they changed it to the definition for mass, both of which would have been okay. Number 15, the higher the temperature of an object, the faster its particles are moving. Jackson?
True.
That one is true. Higher temperature, faster particles. Questions over that one? Did I make any mistakes on anybody's? I graded these while I was sitting at soccer practice, so I was distracted. Augie?
I didn't have no okay on Fahrenheit.
Okay, that's fine. Just still write in Celsius.
I did.
Okay. Elia?
I put false, but then I put false and you made it wrong, but then I fixed it.
Okay, was this incorrect here?
Yeah.
Okay, that's why. Because it was true. Sorry, 15 was true. I didn't write that one up here. Yeah, 15 was true. Okay, go to the lesson 3, the shorter sheet. If you missed any on the front side, I marked it and I drew an arrow to the column it should have been in. The only one that I feel like we had a little bit of trouble with was they are usually invisible, not seen by the human eye. My suggestion when you're doing these, think of examples you know. Think of a solid. Give me a solid, Lainey. Any solid. A soda can. Can you see a soda can with your eyes? Okay. Mason, give me a liquid.
Water.
Water. Can you see water with your eyes? Yes. Braylon, give me a gas. Air. Oxygen. Can you see oxygen with your eyes?
No.
Can you see helium?
No.
Can you see carbon dioxide? So where did that one go? Under gas. That one was kind of tricky. On the back of lesson 3, the true false. I'm trying to hurry, guys. True false on the back. Number 1, evaporation occurs when a gas turns to liquid. Gabe, what do you think? Evaporation occurs when a gas turns to a liquid.
False.
False? What do we call it when a gas turns to a liquid? Not carbonation, that's in soda. Starts with a C. Fisher? Condensation. So you could have marked out evaporation and wrote condensation. Or you could have flip-flopped. Some people drew an arrow over gas and liquid. If you would have flip-flopped the words gas and liquid, that would have made it true. Or you could have changed evaporation to condensation. Number 2, as liquids get colder, the atoms begin to slow down. Jackson?
True.
True. Number 2 was true. Oops, 2, true. Number 3, when a liquid turns into a solid, it's called the melting point. Clara, what do you think? When a liquid turns to solid. False. What do we call that? Freezing point. So you could have marked out melting and wrote in freezing. Or you could have flipped what 2 words? You could have flipped liquid and solid there. Okay, number 4, mass is the amount of space an object takes up. Addie? False. What is the answer to that one? Mass is the amount of matter an object has. That works. Why should that problem look familiar? It was on the front. It was the same one as number 4 on the front because it was in both lessons. Number 5. Every material has its own melting point. Lainey? That one was true. Okay, any questions over lessons 2, lesson 3 check-ins? Okay, so those 3 pieces of paper, your 2 that have grades and your density sheet, you can put in your red folder. If you feel like you need that density sheet out to help you with tonight's worksheet, you can keep it out. So I'm going to pass that out now, and you have about 10 minutes to get going on it, and I think a lot of you guys will finish.